Hello everyone, welcome to my channel Civil Softwares. Today we are going to do frame analysis in SAP 2000. We are going to solve these two problems over here. We are going to at first model this frame in SAP 2000 and then we are going to see its axial force diagram, shear force diagram and bending moment, and similarly we are going to solve this question too. So let's begin. So at first let's go to this question. Go to SAP 2000, go to new model. Okay, at first we always need to see the units. In our question we have kilonewton meter as our units, so it's in kilonewton meter and Celsius. It's okay, so let's go to grid only. Okay, now here we can see in this question that we have this frame. So along x direction we are going to give two grids, 1 and 2. Okay, so let's go to this and let's give two grids along x direction, and in y direction we are not concerned about it, so let's keep just one. And in z direction, okay, let's keep okay, let's say in z direction. Okay, in z direction let's keep one for this, second for this, and third for this. Okay, let's keep three grid lines along z direction, so three. Okay, if we talk about the spacing in x direction, we have 3 plus 2 is 5 meters, so let's give 5 meters. In y direction we are not concerned about it, so let's give 1. In z direction, okay, let's give 3, but we are going to edit it later. Okay, so here we get the xy plane, we get 3D over here, so let's keep it in xz plane. Okay, now let's edit the grid data. Edit grid data, modify. Okay, so we are going to do according to the spacing over here. Okay, so along x direction we have 5 meters and I think it's okay. Okay, it's 5 meters and it's okay. Along y direction we are not concerned about it, but along z direction, okay, let's see, spacing between the first two grid lines in x z direction is between this and this line, so it's 7 and it's 5. That means this distance is 2 meters, so we are going to keep 2 meters and 5 meters. Okay, so along z direction we are going to keep 2 meters at first, then 5 meters in second. So we're just going to click on okay. Okay, so we get this grid line. Now let's go to define. Let's go to load patterns. Let's keep the dead load multiplier as 0. Modify. Okay, now our job is to put the frame member over here. So let's go back to question once. So we have to put a frame here, here, and here. Okay, let's go to the draw frame. Okay, now we are not going to edit anything over here. Okay, and we are going to keep the movement releases continuous. I'll explain you what's continuous and what is pinned. Okay, so at first let's keep continuous over here. So let's go to this point, let's make a frame over here. Okay, similarly we are going to make a frame here also, then finally like this. Okay, so after we are done, we're just going to escape. I'm going to explain about the continuous support and pin support in another video. So for now let's keep it continuous, because okay, let me tell you, if we keep continuous over there here, then it will consider this joint as fixed. If we keep pin, it is not going to transfer any moment. Okay, so we have to keep continuous over here, because uh, it means that it is a rigid support over here, not pin. Okay, not pin, moment is released over here. Okay, if we keep continuous, but if we keep pinned, it's like a hinge, so it is not going to transfer the moments. So considering continuous means like we are welding this. Okay, we are welding this joint, so making it fixed. But if we keep pinned support over here, it's like hinge, so it can rotate freely, like Do you understand what I mean? So it's hinge if we keep pinned, and if it's continuous, it is fixed. Okay, so now let's keep the support. Okay, it's fixed and a hinge. Okay, let's keep fixed support over here. Assign joint restraints, then fixed. Okay, after that we're going to give a hinge support over here. Okay, hinge, apply. Okay, so we are done with the geometrical drawing. Now we are going to assign a uniformly bearing load over this member and point load over here. Okay, let's just give a point load of 10 kilonewton. Okay, so let's just select this member. Let's go to assign, let's go to frame loads, let's go to point load. Okay, here you can see the point load is applied 3 meters from this distance. So we are going for the absolute distance. Okay, we're going for the absolute distance. The load is gravity, it's all okay. So for 3 meters we have 10 kilonewton load, right? At 3 meters we have 10 kilonewton load. Okay, let's just click on apply. Here you can see 10 kilonewton load has arrived. Let's click on OK. So now we need to give uniformly varying load over this member, right? So let's go and select this member. Let's go to assign. Let's go to frame loads and distributed load. Okay, distributed load, and distributed load is of 5 kilonewton per meter. Okay, so let's go and assign the uniformly varying load. Okay, here what you need to understand is load pattern is dead, it's okay. Coordinate system is global, right? It's a global coordinate system, and if we put load direction as gravity, it is always going to assign vertically downwards, right? But we do not want vertically downwards load, we want in this direction, right? In this direction, so it's on x direction, right? So we are going to put on x direction, load direction is along x direction. So let's keep on x direction. Load type is force. Okay, let's not keep on relative, let's keep on absolute distance. Okay, so when you select this, at 0 we have 0, it's okay. And okay, let's keep what is its length? Its length is 5 meters, right? So at 5 meters I am going to give 5 kilonewton per meter. Am I correct? Yes, 5 kilonewton per meter at 5. Okay, let's apply and see what happens. Okay, apply. Okay, so in this way we can get this uniformly varying load. Let's click on apply. Okay, now you can see this 10 kilonewton load is gone. So you can just go to display, go to show object load assigns, go to frame, then just click on apply. It is going to show all the loads. Okay, apply. Okay, I want to say one thing. If you are confused about this here 10 kilonewton load is arrived here, but okay, let's click here, let's go to display, let's go to object load assigns, frames, and apply. Then it is going to give here also. Okay, so in this way we have modeled this uh, frame quite easily. Now let's just close this 3D window and let's just keep this only. Okay, now I'm going to run the analysis and see the deformed shape and axial force diagram and shear force diagram. Okay, let's click on run analysis. We are not going to run the model case. Okay, do not run this case, and we are just only concerned about running the dead load case. So run now. Okay, let's just save random name practice number 1. Okay, save this. So it is loading. So in this way you can see the deformed shape. If you want to see the animation, you can just click here, start animation. Now the member behaves, you know. And if you want to see the joint reactions, support reactions, just go to this place, go to joints, then click on apply. Okay, it's going to give the values in arrow in this way, in x and y direction. Okay, now if you want to see the bending moment diagrams, axial force diagram and all, you can go to this option over here and frame cable tendons. Then if you want to look for axial force diagram, okay, it's an axial force, click on apply. This is our axial force. If you want to see shear diagram, apply. This is how it looks, shear force diagram. For a moment, go to this, go to apply. Okay, now this is how you can see this. Now if you go on this member and right click on this option, you can see uh, resultant shear, you can see the resultant movement, deflections, everything you can see of this particular member. Okay, you can see the deflection. And so in this way we can model this frame. Now let's go to another question. Okay, let's go to another question. Let's just click on file, let's go to new model. Okay, now so we are going to next question and solve this one in our next video. Thank you guys, see you in the next video. Bye bye.